Welcome to the lecture on Intrusion Detection Systems or IDS. Previously, we discussed the cyber kill chain and its different phases. We also saw how security defenders basically interact or respond to each of those different phases in the incident response lifecycle. Now we're going to discuss intrusion detection systems, which after the firewall are basically your first line of defense. So it is the job of these systems to detect any intrusions. Because unless you can detect an intrusion, how can you take action against it? So alerting to any type of intrusion is very important from a security perspective, and that's what we're going to discuss today. You can think of intrusion detection systems as sort of a security guard, which basically listens to all the network traffic, everyone coming in, going out, and then the basic job is to detect any kind of intrusion, which could be exploits against the operating systems and applications, it could be SQL injections, cross-site scripting attempts, or data exfiltration attempts. Now, there are two big variations of intrusion detection systems. The first one are called intrusion detection systems. Their job is only to detect intrusions. That's it. So once they have alerted the system about any possible intrusion, their job is done. The rest is up to the security defenders to take action and follow up. The other type of intrusion detection systems are what we call as intrusion prevention systems. So these systems, they go one step ahead. They also have the IDS capability, that is the intrusion detection capability, but they also have the capability to actually stop the attacks. So they not only detect intrusions, they can also stop intrusions. So IPS is basically IDS plus the capability of stopping intrusions. Now, in the intrusion detection ecosystem, there are two different concepts that you must be aware of. So the first one is called misuse detection. This is the first strategy. The idea behind misuse detection is that it protects against potential insider threats. What do we mean by that? So basically we define that what is abnormal behavior, and then we check whether that abnormal behavior has occurred or not. And if yes, then we have detected a misuse. To give you an example, let's say we have defined that if repeated failed attempts to access financial records is detected, then that's an abnormal behavior. So if you're using the misuse detection strategy, then if there are repeated failed attempts to access financial records, then a misuse detection alert would be generated. Now this approach is great if you already know exactly what can go wrong. However, it's not that effective against new attacks. The reason being that you have to define the abnormal behavior, and sometimes you may not have foreseen all the possible different abnormal behavior or attack attempts. So, misuse detection can only work against known attacks or known patterns which you have already fed to the system. So, for simple cases, this is a great approach. But if there is a possibility of new attack vectors, a new approach, or evolved malware, then this approach is not that great. So we move on to the second approach, which is anomaly detection. So this protects against outsider threats. And what's the basic idea? The basic idea is that we define normal behavior, and then any behavior which is deviating from the normal behavior is basically an anomaly and an alert is generated. Just to contrast it with misuse detection, in misuse detection, we define the abnormal behavior that, okay, if this occurs, this pattern occurs, then this is an abnormal behavior, generate an alert. In this one, we're saying that this is what's normally supposed to happen. If anything beyond this happens, so this is our sort of like baseline. So if anything happens beyond that, then that behavior is considered an anomaly and an alert is generated. Let me give you an example by using login as an example. So let's say you can say that for a normal user, he may have, let's say, 2 to 3 failed login attempts in a week, because sometimes people mistype or something can happen, maybe the caps lock is on. So 2 to 3 times a week is normal. But anything above and beyond that, so for example, more failed attempts, it may reveal a malicious attack or someone trying to guess the password. So in that case, as soon as that threshold is passed, an alert is generated. So this type of strategy is great for detecting new attacks because we just define the normal baseline, and then anything beyond that is considered an anomaly, and an alert is generated. From another perspective, let's say your network receives 1 gigabyte of traffic from outside, and then there is roughly, let's say, 1 to 2 gigabytes of traffic which flows from your network to outside systems. So it's very easy to already sort of benchmark and create a baseline. Now, if anything happens, let's say there is a data exfiltration. Now that threshold may pass and then an alert would be generated. The point I'm trying to make is that defining the baseline is pretty simple, and then you don't have to think about all the different possibilities which could go wrong. Anything which is beyond that threshold would be alerted against. Whereas in misuse detection, you would have to specifically define each malicious behavior or abnormal behavior. So, as a rule of thumb, generally anomaly detection approaches are the most widespread in industry and the most effective. Now, let's take an example of an actual corporate network and then understand what are the different points or different places where intrusion detection systems work. So, this is a corporate network. They have a firewall which is facing the outside world. And then there is the gateway, which is an entry into the corporate network. And then you have databases, maybe servers, those kind of things. Now, the first type of intrusion detection system is what we call as network intrusion detection system, which is placed on the network. So the job of network intrusion detection system is to monitor packets on the network and detect intrusions. So all of the traffic that's going this way, a copy of it is also sent to this network intrusion detection, which then basically analyzes it and processes it. But let's say some traffic has already bypassed the firewall. You can also have log file monitors. Basically, these type of tools, they monitor server log files to detect patterns of intrusion. So for example, they have the timestamps and then which process and what message was generated and so on. Another type of intrusion detection system is system integrity verifier. These type of tools, they verify the integrity of system files to ensure that an intruder has not modified them. So Tripwire is a very popular product and it uses file hashes. So what it does is that it basically creates a hash of the files and then periodically checks if anything has been changed without authorization or permission. So if anything happens, any file has been modified or something has been added to a file, it has been corrupted or anything, then Tripwire is going to alert you. So you have several different strategic places where you can use these tools. Now there are two big families of intrusion detection systems, host-based and network-based. And the way that they operate and monitor traffic is a bit different. So let's explore that. So let's start with host-based intrusion detection systems or HIDs. These are installed on end systems and they monitor the incoming and outgoing traffic from a specific host. So they're not monitoring the complete network traffic, they're just monitoring the traffic for this specific host. So any traffic that is going inside to this host or originating from this host, that is being monitored by HIDs. In contrast, the network intrusion detection system is always installed on the network itself and it monitors the network traffic. And it also monitors network-wide log files stored on servers. Now, the way that you have architected your system in terms of security matters a lot. So the location of where you place these NIDs matter a lot. So for example, if you place it here, this NIDs can basically detect intrusions that have bypassed the external firewall. So your first line of defense was this external firewall, the public facing firewall. But if malicious traffic has somehow bypassed this, then this NIDs is going to detect that traffic. But what happens if, let's say, that traffic was able to bypass the firewall as well as the NIDs? Well, here is what we call as defense in depth. You should have layered security. So you can install a network intrusion detection system here as well before accessing your database. So any malicious traffic that has bypassed the external firewall, the basically NIDs which was inside that gateway, and the internal firewall, you'll still have another layer of defense here. And this is where someone may try to basically access the database or run malicious scripts against it. So what are the challenges of intrusion detection systems? Now, an IDS or intrusion detection system can only detect malicious traffic since it only receives a copy of the packet. So let's say some traffic is coming in. Now what happens is that one copy will be passed to the internal corporate network and one copy would be sent to NIDs. And then nets can basically run the forensic analysis and try to detect attacks. But let's say even if there is an attack, right? But this traffic has already entered the corporate network. So this is one limitation of intrusion detection systems. And that traffic is going to basically do whatever it was intended to do. So yes, you have been alerted, but the damage could already have been done. So what's the solution to this? The solution to this is network intrusion prevention systems. So these systems go one step ahead. They'll not only detect malicious traffic, they'll also stop it. And that's what we're going to discuss next.